Hi, I'm Dan. As Carlos mentioned, I lead engineering at Glean, and we're going to talk about DataOps today. So when I use that phrase DataOps, usually the immediate next question is, what do you mean? What is DataOps? It's a phrase that is thrown around a lot more often these days, and I think different people have different perspectives on what DataOps actually means. So let me start out by giving my pitch of what DataOps is and why you should care about it. Here's what we do, right? We take data about our business, we write pipelines and build charts and dashboards to try to understand what that data is telling us. Hopefully that data leads to better business decisions, and then those decisions end up back in the data, right? So that's business intelligence in a nutshell. It's what most of us are doing at a high level. I've been in this industry for a while, and usually it's quite a bit more complicated. It's probably not controversial to say. There's a lot of different stakeholders at the end of that cycle. They all have really different needs from the data. They also have different levels of familiarity with using data and using tooling around it. We have engineering teams that are writing pipelines, moving data around, trying to understand what all these downstream people need. And then, of course, we have lots of different kinds of data practitioners, data analysts, data scientists, machine learning engineers, quality teams, that are all trying to model this data, figure out what it's trying to tell us, and empower the rest of our stakeholders. A lot of feedback loops between these groups, right? We have the data people talking with the stakeholders to understand their needs. We have stakeholders teaching data people about the business. We have bugs getting sent from stakeholders all the way back to engineers. And then finally, we have a lot of tools. And in particular for this talk, I'm focusing on the BI tool, which varies depending on your business, but usually you're putting it in between the data and all those stakeholders. And usually the objective of that tool is to scale the data team. We want to help those end users use data on their own, answer questions on their own without having all day to send questions to data people to help them figure it out. So that's where we want the BI tool to be successful. And I think a really key part of that is establishing trust, right? If the end users don't trust the data that they're seeing in that tool, they very, very quickly are going to stop using it. And then all this work that we've put into making the model work correctly is kind of going to waste. So trust is like the currency of the data team, and it's really critical to make sure that trust level stays high. And in my experience, there's a whole class of questions that those stakeholders are often asking that get in the way of that trust. And they're kind of questions that I think shouldn't really exist anymore. It shouldn't happen in 2023. And I actually heard these kinds of questions come up in like 4 or 5 different talks over the last few days. So I know it's really top of mind. They're very operational in nature. It's questions like, why does my chart suddenly look different? Or when we push this new data model, will my BI tool that I'm depending on still work? Or I'm looking at this table and it kind of looks broken. It doesn't align with my intuition, but I'm not quite sure why. It's all about change management. And I think despite all of these tools we've been throwing at the problem, BI is often a really fragile part of the stack. You're always kind of worried whether it's working correctly. And this to me is what DataOps is really all about. It's about looking for principles and techniques and patterns that we can use at the top of the stack and the visualizations to make it feel a lot less fragile, and in particular, using code to accomplish that. So borrowing principles from engineering and other disciplines to start using code and automation to make BI feel less fragile. So in the talk, I'm going to talk a bit about why this has been hard, like why hasn't DataOps really exploded, I think, compared to other kinds of engineering ops things. I'll give a pitch for how I think we can make progress, how DataOps can start to fix those problems, and then walk through a few practical strategies that you could use in your own company to start going from 0 to 1 in your DataOps journey. So a bit about myself first. So I started off my career, I'm a software engineer. I worked in Google Analytics, so we were helping advertisers understand their data. And from there, I moved on to, at the time, a small company called Flatiron Health. And our job at Flatiron Health was just to connect with oncology clinics, so doctors that were treating cancer patients. We would ingest data from those clinics about the patients, try to extract out useful information, clean it up, model it, and then provide it back to clinicians and researchers and scientists so they could use that data to understand how is cancer being treated in the real world, which treatments are working better than others. And so even though this was a pretty technical domain, there were a lot of non-tech details in there, it really was just a big business intelligence problem. And that's actually where this diagram came from. So we had a lot of different stakeholders that knew a lot about the business. They had really deep expertise in their areas of ownership, so medicine, pharmaceuticals, manufacturing, and they also were very motivated to use data. They were very data literate, but they weren't particularly technical. They were not going to sit down all day and write Python or SQL to answer questions. So our job as the data team was to help them, right, to get data into their hands and have them explore it on their own and use it effectively. And it turned out this was like a really hard problem. Putting aside all of the challenges of cancer treatment, just moving data to a place where non-technical people could use it was really, really hard. And there was a lot of things that went into making it hard, but in particular, these operational problems were really hard for us to solve. These things were constantly breaking, and these clinicians who had plenty of other important things to deal with would lose trust in the data really, really quickly. So a lot of the problems that we encountered at Flatiron Health inspired where I am today, a company called Glean, founded by my colleague Carlos, who also worked at Flatiron. We're building a BI tool that attempts to make this problem better. And in particular, I'm focusing on the operational parts of it today. And when I look back and think about why was this so hard, there's a few gaps that came to mind that I felt like we were missing, and it feels like it's kind of missing in a lot of these situations. First one is that it was really hard to version control things. So when something would change and we would get a question like, hey, why does this dashboard look different? It was very hard to answer. Did somebody change the dashboard? Did my team change it? Did you change it? Did the data change? We were kind of on this mystery quest every time a question came in. It took a lot of time. There were also not really many tests, and especially not integration tests. And this meant we would push a change. It would have a bug in it. A month later, a doctor would say, hey, this data point just looks wrong. I don't think it's correct. And they'd be right. And as an engineer, like that's the last thing I ever want to see happen, right? If a user is bringing you a bug that's really critical, it's a strong signal that there's many missing opportunities for testing and validation in between the thing you built and giving it to the user, right? So when we're building an application, there's so many checks and balances we try to put in to avoid that happening, and it felt like we were doing very little of that when we were building charts and dashboards. There wasn't much automation either, and this became a problem when there were changes that spanned different layers of the stack, which is frankly what we were doing like almost all the time, where we were changing a pipeline, we were changing a database, and we were changing a dashboard, and that needed to be done by a human clicking buttons, and it was really error-prone and often led to a lot of mistakes. And finally, overlaying all of this was a really slow development cycle. So when there was a bug or when a user had a great idea for a new data point to expose, there was a lot of picking up the laptop and like tweaking the chart for them and asking if it looked good, and then going back to my desk and coming back a week later, but they were busy. There was no easy way to send them a draft. There's no easy way to like collaborate asynchronously on this stuff, which again meant that people sent us feedback less often because it was taking so much of their time. So looking at these challenges kind of end to end, it reminds me of a really similar problem that happened in a different area of engineering about 10 years ago or so. So picture yourself in 2014, there's this new thing called the cloud, new-ish thing, and there's this big migration from on-premise infrastructure to cloud-based infrastructure. And in those early days, a lot of this was done pointing and clicking in cloud UIs, setting stuff up, and it felt very fragile. And actually, a lot of the problems that I just mentioned were happening to these folks as well, right? Oh, we don't know how to version control the changes to our infrastructure. We don't know how to test this, and we keep pushing things that are breaking. Suddenly, when you can change a lot more about your infrastructure quickly, it introduces the need for more tooling and more like disciplined practices. And I see a similar thing happening in data, where we have all these new tools, but fewer practices and patterns to make sure that they stay safe. So the solution in the ops world, in infrastructure, was DevOps, which is now par for the course, right? Back then was a pretty revolutionary idea, which was we're going to take this operational thing, managing cloud infrastructure, and we're going to treat it just like software development. We're going to have code, that represents what we want to do, check it into Git. We're going to use pull requests and code reviews and approvals. We're going to write tests. We're going to write automation. And it turned out this was a really good idea. And it solved a lot of the operational friction that often happens when you're doing infrastructure work. And it wasn't just DevOps, right? So if you look at the whole data stack, over time, really the last 5 years or so, there's suddenly been a lot of excess code getting applied to different layers, right? We have Terraform and DevOps. ETL, 10 years ago, I used to be running SQL scripts manually on a schedule. I'd have calendar invitations remembered to run the script, right? But now we have tools like Dagster, and before that Airflow represented as code. I can test it, I can serve it on a schedule. And then after that, we have DBT, where these data transformations used to be spread across our different systems. Now we have a data model we're checking in. We can deploy it to a staging environment. We can review it. We can preview it. All these good practices that we've inherited from other areas. And so I think BI is the missing link here. We haven't quite coalesced around a standard way of managing this stuff as code, or at least with good engineering practices to prevent this stuff from breaking. And that's, to me, this is like how DataOps fits in. It's not a new idea, right? Like, code can be good. A lot of us know that. I'm not the first person to say this. So why hasn't it happened? Why is DataOps not as ubiquitous as DevOps in terms of practitioners? There's no hiring a DataOps engineer, right? Even though there's plenty of that for DevOps. I think there's a few reasons. I think that BI is kind of uniquely different than most other areas of engineering that have made DataOps a harder thing to kind of make it stick. So I'll list out a few challenges. So first, and I think probably the most important one, is that BI has a really wide range of use cases. There are times when you want a really governed set of metrics that never break. You have dashboards that are critical for your business. Executives are making million-dollar decisions. It's really critical that they're always correct and version controlled and approved. But on the other hand, often the most powerful part of data is the more exploratory mode, where you are having hypotheses, collaborating in real time, digging through the data, coming up with new charts. And that kind of improvisational exploration is really critical to data being well, and it doesn't really suit itself to the kind of light friction you apply to something like writing something in code or doing a code review. And so I think whatever solution we come up with for DataOps, it has to bridge those two worlds really naturally. You have to be able to treat some things as important for code and some things not, and have that be a really seamless switch back and forth. Beyond that, BI is inherently visual, much, much more so than other kinds of engineering. So in DevOps, I can look at a Terraform plan, and I can see that it's adding 3 EC2 hosts and a new database and a new schema, whatever, and I can be pretty confident I understand what it's doing. But I can't look at a JSON file or a YAML file for a line chart and be confident I know what it's going to do. I really have to render that chart. I have to see it in the context of the data. I probably have to show it to somebody else and get validation that it's correct. And I think that makes the whole doing it as code kind of challenging. It's also much more interdisciplinary. So when I'm writing Terraform code, my reviewer is also an engineer. They know how the code works. They've done code reviews before. When I'm building a dashboard, my user is an executive or an operations person, right? The product is the data. The user is everyone else. And they may not be used to writing code. They might not want to write code. And that makes it challenging to fit into the system. And then finally, there's inherently a really big number of dependencies. So your BI stack is at the very bottom of a very, very long chain of dependencies going through DBT and Snowflake and Fivetran and your application itself and 20 vendors that are piping you data. And any change in any of those systems could potentially be impacting the correctness of your BI stack. So that just makes it really hard, right? And I think that's, a lot of us spend our time trying to manage all that chaos, and it's a bit harder to take a step back and think about how to make it a bit more of a process. But I think we can solve it. Like this is kind of the challenges we're looking to solve. And so I'll walk through a pitch of how we can start thinking about dashboards as code to get around those challenges. So here's a diagram of a BI tool. It's pretty generalized. So you have data on the right side there. You have your DBT pipelines that usually live in code somewhere. You have some modeling layer, and there's a lot of different ways you can do that. Probably you've heard 5 different options over the last 2 days, right? It could be a model built into your BI tool. It could be a semantic layer. It might just be a SQL query. But at some level, somebody is saying, here's how you go from my raw data to my core concepts and the metrics I'm trying to measure. Then you have your charts and your tables and your graphs that visualize the data. And then you have your dashboards that pull them together and are used by your stakeholders. Right? So when you lay it out like this, it starts to look familiar. It starts to look like a DAG. It's a DAG just like dbt is a DAG and your database schemas are a DAG. And by DAG, I mean it's a graph of things that depend on each other, that have relationships that you can define as a graph. Right? And once you do this, we can start borrowing the data structures and techniques that we've used elsewhere for representing DAGs. Right? So dbt uses the file system. We can do that as well. So here's how Glean, the tool that I work on, represents this DAG. We have the data, we have the model, we have the views, the dashboards, and you can imagine to the right, there's your dbt and your database and your application. I've even seen a few different diagrams like this in other talks. So let's treat them as files maybe. Let's say each of the nodes in our BI tools graph is a file. We can reference other files. We've now overlaid some code onto this thing. Could work, but remember our big challenge here, not everything might need to be in code. The code might be getting in the way. So the graph that we're designing needs to be hybrid. It has to support some nodes that live in Git and are governed, and some nodes that live in the BI tool and are not quite as governed, right? And this is a solvable problem, right? We can maybe have an ID system that is spanning all these things, and you can reference a resource by its ID, and then have a separate mapping that tells you, is this ID in Git somewhere, or is it in the BI tool? Cool. So that's the first challenge, but then we have the visual nature of it, right? I can't look at this code and see if it's correct. So to me, this challenge is about the tooling. It's about the IDE. I kind of think we need a better IDE for developing BI so that you can switch back and forth between code and visuals quickly. So here's how we think about it in Glean, and let's see if I can get the video working. There we go. So this is Glean. Anytime you're looking at a visualization, you can pull out a code editor. And the code editor will be showing you the deterministic config that will generate the thing you're looking at. And there's two-way binding between both sides. So as I edit the visualization, I'm breaking out, I'm exploring, I'm pivoting, I'm doing probably kind of complicated filtering. All of that is automatically syncing to the code representation on the right. Vice versa, if I edit the code, I see those updates live in the graph. And I have things like autocomplete and inline documentation. And so this is a learning tool, right? You can use this to learn the language of the BI tool. And it's also an accessibility tool. So if I have an end user who wants to propose a change, they can just make the change, and that syncs to the code automatically. If I'm an engineer and I have a template somewhere that kind of I've already written up, I can paste it in. So even without touching a file system, we've started to tighten that feedback loop between the code representation and the visual. So, thank you. Guess I like it. Now I have to figure out how to get back to the slide deck. There we go. Cool. So visual is good, but code is good as well, right? We're engineers. I think one of the reasons dbt has become so popular is you can use your usual tool chain, right? You can use VS Code and command line and everything you're used to. So we can copy this code to VS Code as well. We can even have it live alongside your dbt code. And suddenly we have one unified ecosystem to do BI development alongside our data development. And that opens up things like change tracking. We can have a git commit that shows which of my resources are changing and which are not. And in Glean, we were inspired a lot by Terraform. So for those of you who haven't used Terraform, you can define changes and then run a plan. And Terraform will tell you which of your changes are yet to be deployed into AWS or Google. So we've built a similar thing for Glean. You can preview your local file system, and you can see here are the views that I'm adding, here are the things I'm updating, here are the things I'm deleting, and here are the things that are unchanged. But remember, this list itself is useful, but maybe not so useful if I can't see it. So this comes along with a visual preview as well. And I think I have another video next. Yeah, so I can review this. My chief marketing officer can't. And so jumping back to a video. Here we go. For all these builds, I can click a link. I can jump into the tool, and then I can get a visual preview, not just of what I'm changing, but of my whole DAG. So everything that's been built out, including what's in code, including what random people have built on their own, I can see with that yellow border around it, here's what this will look like if I were to make this change. And this is a permanent URL. I can send it to my stakeholder. I could send it to the person reviewing my change. And we can explore it. We can even change it, right? We can say, you know what? This is not quite right. I want to change the visual presentation of this chart. And you can do that right in the tool. Back to the slide deck. There we go. And then when it's looking good, we can run a deploy, which is just like how Terraform works. We can say, all right, I approve this change. I want to deterministically apply this to my org. And now everyone using Glean can see the things that have been changed. Now we have an opportunity to write some tests, right? So once this is all done through a CLI, and I think that's also a pretty important part because a CLI can be automated and it can be composed. So you can take a CLI, you can put it in a GitHub action, you can put it in the continuous integration system, and you can hook other stuff into it. So testing, remember we have all these dependencies, right? We would like to do some things in an automatic way to prevent broken stuff from happening because of dependencies. And now we have an opportunity to do that. So when we try to preview some changes that I'm making, the BI tool, Glean, can do a bunch of checks. We can see, hey, are the tables that you're trying to read from lining up with how you've configured the graphs? And you can kind of imagine the sky's the limit for the kind of logic you can put into these tests. Maybe you want to test that the graph is always going up, or that there is exactly 5 data points in this chart, because if there's more or fewer, we're doing the calculation wrong. Right? So it's all about coming up with primitives, foundational building blocks that you can then tie together and start adding automation to. And I think this becomes especially powerful when you start dealing with changes that span layers. So suppose that you're changing a DBT schema, there's a new column or a renamed column, and to make this work well, you also have to change your BI tool. This is where I think most of us get into trouble because it's that manual coordination across different layers of the stack. But with these kinds of primitives, we can start building up patterns to test these well. So for instance, I can run DBT at a target of a dev schema. I can generate a preview of my whole BI stack reading from that dev schema. I can review it. I can send that to a stakeholder. I can make sure the data looks right. So this is helping us validate the data as well. I can now review both of those changes together. Right? I can send a pull request that's saying, hey, I'm changing this column. I'm also changing this in my BI tool. They're in the same repo. I can make sure they all line up. And when it looks good, we can also deploy them together. And this is what we do internally with our own data inside of Glean. We run DBT on Airflow, and then we immediately deploy our own Glean assets to Glean. And that way, we're guaranteeing that if something's not right, we'll get notified. But otherwise, the BI layer and the data layer are always in sync. And I think this is kind of the thing we should be striving for, is patterns to help those transition points between layers stay in sync. So last section here, I'll walk through some ways you can start putting these strategies into practice. And a lot of it depends, I think, on your use case. Do you have a lot of governed metrics that are really critical not to break, but a lot of stakeholders that are very motivated to explore on their own? Maybe you have really critical dashboards that need to be versioned in a really granular way because they're super important. How do you want your engineers and your stakeholders to collaborate? Sometimes you want them sitting side by side, talking literally every day. Sometimes you want to put in layers in between. It all depends on the information flow in your business and what you want to put in place. And deployment schedule is also a good question. So are you building things that are changing every day, every week, every month, every quarter? And how should that impact how your automation works? These are very similar questions to what we ask about application deployments and data deployments, right? So it's all about taking those same operational best practices and thinking about it even when you're building out a chart or a dashboard. But I'll walk you through a few examples. This one is probably the one we see most commonly inside of Glean. So you version control your model, which could be your SQL, could be the metric calculations, and you leave the rest of your visual parts unversioned, or at least not checked into Git. And this gets you the advantage of syncing together your data stuff and your BI stuff so it doesn't break, but it leaves a lot of flexibility for your end users to explore on their own. And this, I think, is especially useful in these interdisciplinary organizations where you have people that want to use data and don't need a lot of help to do it. It does require that you have a pretty mature model. So if you have a data model that is pretty easy to come up with just nonsensical data or data that's wrong, this gets a bit dangerous because those users can kind of go off track. So it works best when you have a mature model, you're pretty confident that the things you can do with it are accurate for the business, and now you want to let everybody else have a lot of freedom. So that's one approach. You could also think in terms of vertical slices. So maybe there's a path from your database, through your pipelines, through your charts, through your dashboards. That whole path is a critical path. And the number coming out of the end is controlling a big investor decision, and it should never change without your approval. But there's plenty of side quests that come off of it that are okay, right? So this is another way of thinking about it. You check in to get all the parts of that critical path, which helps you control it. Of course, there's now a little bit more friction to updating that end result. Could be good if it's a really critical thing. Could be not so good. Depends a bit on what you want to do. And the last one I'll leave you with doesn't really exist yet. We do it a bit in Glean, but I think there's a lot more to go. Again, inspired by DevOps. So in the early days of DevOps, we were working at a very low level of abstraction. But today, if I want to bring up a new stack of EC2 servers or a database in AWS, I can import a module that's been written by somebody much smarter than me with a lot of best practices. And I can focus on how am I going to customize this best practice thing and deploy it to my organization. And I think that the BI is just ripe for this pattern to evolve. All of us in this room are doing a lot of duplicate work. We're doing very similar things. If you're a SaaS business, we have similar metrics, we have similar dashboards, we have similar pipelines. So why can't I import retention curve template, plug it into my data, and have it build a bunch of good charts and dashboards to start with, right? There's still going to be plenty of customization, but I think this is going to happen because once we can do it, it saves us just so much time. To get there, though, we do need those building blocks. We need code representations of the core parts of this. We need automation to plug it in. Once we make it work well, we can start building these higher level abstractions and really start sharing best practices programmatically instead of spending a lot of time talking. But it's still early days. A lot to invent. DevOps is par for the course, but DataOps still don't quite agree on always what it means. I'm very excited for this to start moving up the curve because there's just so much more you can do when you have code that you can operate on, right, in this space. So, summarize, fragile BI leads to lack of trust, which is the core currency of the data team. The idea of DataOps is to improve that trust by making things feel less fragile, borrowing engineering principles from other areas to do it. But it's really hard, and it's been hard for a while. And to do it well, we need to figure out ways to bridge the gap between the UI part of BI and the code part of BI, between the engineers and the data scientists and the stakeholders, come up with tools that they all love and work with together. And if we can unlock that, I think it's going to be very powerful. That's it. So yeah, quick plug for Glean. I have these little cards somewhere. You can get a free project in Glean, and you can build a dashboard with code. We have some T-shirts, I think, to hand out. We'd love to chat about any of this. We think about this a lot. And yeah, thanks a lot.